Hello viewers, good morning and welcome to my page this morning. So today we'll be taking another top subheading on geometry, which is circle geometry. And in circle geometry, like I've said before, we have so many theorems that we can use in circle geometry, but we're going to recall each of the theorems as we face each problems because each problem has its unique theory to the solution. So let's begin. In the figure below, PQRX are points on a circle center C. QP, that is the line QP, is produced to X. If XPS is equal to 77 degree and PSO is equal to 68 degree, find PQO. All right, so let's go about it. Don't forget that, let's take solution first. Don't forget that it is given that XPX, which is angle P, is 77 degree. Now, what it means is that, and don't forget that angle is formed as an exterior angle. This is a quadrilateral. PQRX, PQOX is a quadrilateral. Also, PQRS is another quadrilateral. And this 77 degree, which is angle P, is formed outside of the quadrilateral as an exterior angle. So we can conveniently say, because we have been asked to find PQO, that is the angle Q. This is the angle they are asking us to find. PQO, which is this angle formed here. How do we get it? Now, before we go there, don't forget that this is an exterior angle. So we can start by finding the angle QRX, which is angle R, the angle formed here. So we can say that the angle QRX is equal to 77 degree. How is this angle equal to 77 degree? There is a theorem that states that the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. So that is the theorem we are going to use. The exterior angle of a cyclic quadrilateral is equal to the interior opposite angle, which means this angle that is formed as an exterior angle of a cyclic quadrilateral is equal to the interior. This is the interior opposite. This is the opposite angle. So that means we state our reason: exterior angles of the cyclic quadrilateral angles. These are right angles, a short form of a cyclic quadrilateral. Quad is equal to the interior opposite angle. Okay, so let's proceed. Also, from there, we can also look for another angle, which is the angle formed at the center. Don't forget that the angle formed at the center, we can call it angle O. That angle formed at O, we can find it by using a theorem that states that the angle at the center of a circle is twice the angle found at the circumference. And there is an angle formed already at the circumference, which is angle R, that we've gotten as in 7, which means the angle formed at O will be twice that angle. So let's say QO, that is angle formed at O, X, will be equal to 2 times 77, which will give us 154 degree. Our reason is angle at center equals twice angle at circumference. That is the reason we are using that the angle formed at the center of the circle is twice the angle formed at the circumference. Okay, so let's proceed. Now that we've gotten this angle, we may also decide to get this angle. How do we get this angle? That is, from this point to this point is 77, but we don't know the interior angle here. So how do we get that angle? That angle can be referred to as angle QPX. So how do we get angle QPX? We can say that angle QPX is equal to angle QPX is equal to 180 degree minus 77 degree. Why do we say so? Don't forget, the angle formed at P, if you add it to the angle, this 77, they are supposed to give you 180 degree. The reason is that they are formed as straight line. Angles that are formed at the straight line, this is a straight line. Angles formed at the straight line sum up to 180 degree. So our reason is straight line angles. Our reason is straight line angles. So that is our reason, which means that we're going to get at QPX is equal to 103 degree. Okay, so let's proceed. Now that we've gotten the angle here, we know the angle here, we know this angle, we can now get the angle Q that they asked us to find, which is PQO. So therefore say that angle PQO, therefore angle PQO will be equal to 360 degree minus the angle at the center, which is 154 degree, minus the angle at this point, 68 degree, minus the angle formed in this interior here, which is 103 degree. What is our reason? Our reason is very simple. Sum of angles in a quadrilateral, this is the quadrilateral PQOS is equal to 360 degree. So that is our reason. We're going to write it here, sum of angles in a quadrilateral. So that is our reason. Then we're going to subtract all this together. When we subtract them together, we are going to get the figure 35 degree. So this will give us, by the time we subtract all this, we'll get 35 degree. Therefore, PQ, the angle PQO is equal to, therefore, the angle PQO is equal to 35 degree. And this is our final answer. I hope this class was so enjoyable. Thank you for joining me. Please don't forget to like, share, and comment. And if you're watching from YouTube, please don't forget to subscribe to my YouTube channel. See you in my next video. Bye.